All right, so in 1B.9 part 3, applications of rates of change notes, essentially what you're going to look at is everyday problems that involve average rate of change. Okay, and they're pretty basic from start to finish, but it's just, can you see all you're doing in this situation is subtracting and dividing, subtracting and dividing. Identify what's your independent, identify what's your dependent variable, and it's the change in your dependent over the change in your independent. Okay. So for each one of these problems, what's going to happen is I'm going to give you a chance to process. Okay, you are going to do it. And then we're going to come back together and we're going to check what you did. I'm going to strongly encourage you not to just wait till I do the problem. That is not how you learn. Okay, you learn from trying and correcting your mistakes. All right, so the first problem is up for you to try. Ask your group questions, talk to each other, work together. And so up first, you have a speed of a car. This is a physics application, a basic physics application. Our car travels from one city to another. It covers a distance of 150 kilometers in 3 hours. What is the average speed of the car? Go. Okay, so up first, we have to identify what's our independent and what's our dependent. So what would be our X and what would be our Y? So for this problem, what is our dependent variable? Kilometers, our speed, our time. This is our dependent, right? This is our change in our Y. And so our independent would be the 3 hours. That would be our change in our X, right? And we're finding the average rate of change, which is the change in your Y over the change in your X. So that would be 150 kilometers over 3 hours, which means that you are going 50 kilometers per hour. Agree? So again, you identify what's your dependent, what's your independent, find their difference. Okay? This problem, it was given straightforward to you, correct? All right, let's try another one. Okay, the population of a town increased from 20,000 in the year 2000 to 25,000 in the year 2020. What is the average rate of change of the population per year over this period? Find your change, find your dependent, find your... 10 more seconds. All right, fine. So my independent, my change in X would depend on what? The years, 2000 and 2020. So 2020 minus 2000 equals 20. My dependent change would depend on what? The population. So we have 20,000 and our end goal, our end game is, so we have 25,000 minus 20,000, and that gives me 5,000. So can I find my AROC? Yes. Remember, it's your change in Y over your change in X. What is our change in Y? 5,000. What's our change in our X? 20. Cut off those zeros. What's half of 500? 250. So the population has grown 250 per year. That says people. I know it doesn't. It looks weird. So I'm going to rewrite it. But in my mind, I was writing people. Okay? Yay, nay? All right, next one. You have the temperature in a city changed from 10 degrees Celsius at 10 a.m. to 25 degrees Celsius at 2 p.m. What was the average rate of temperature change? Another 60 seconds on the clock. About 15 seconds left. All right. What is my change in my independent? What is my independent? The hours. I went from 10 a.m. to 2 p.m. What is the change in that time? 6 hours. My change in my dependent, my delta Y. I went from 10 degrees Celsius to 25. So 25 was my end. 10 is where I started. So that is a 15 degrees Celsius change, correct? Do I have everything I need for the rate of change? Why, yes, I do. So that's going to give me 15 degrees Celsius. A big old degree symbol. Over 6 hours, which becomes what? Degrees Celsius per hour. Okay. Next, economic example. A company's revenue grew from 1 million in 2018 to 1,500,000 in 2023. What is the average rate change of the company's growth? Oh, 5 seconds. Sorry. And yeah. All right, change in our independent. What was the change in our independent? 5 years. Your independent is your time. So the change in that would be the 2023 minus 2018, which is in years, right? The change in your dependent would be the growth in their income, the revenue, I'm sorry. So 15, what, 1,500,000 minus 1 million. I should just wrote K's. I don't know why I wrote it all out. And that's going to leave us with 500,000. So I wrote 500K. And so your average rate of change would equal 500,000 divided by 5 years, which is 100,000 per year. Per year. By the time we're said and done, y'all are going to be expert average rate of change finders. All right, here you go. Another one. Water level in the tank. What's happening? How's it changing? It's increasing. So your arbitrary change should be positive. I'm going to give you a little shorter time. Let's go for 15 more seconds. 4, 3, 2, 1. All right, what is the change in my independent? 3 what? 3 hours. What's the change in my dependent? 6. 6 what? Do I have everything I need? So that is 6 meters divided by 3 hours, which leaves us with 2 meters per hour. All right, 60 seconds or less. Go. Twenty seconds. Okay, what is the change in my independent? What y'all put? So notice how it's written as our per. So in liters per kilometer, this lets you know that this has to be your change in Y, and this has to be your change in your X. So how the units are given to you, that's how you know which is which. Make sense? So for our delta X, that would be our 240 kilometers. Our delta Y, that would be our 30 liters. So that means it'll be average rate of change equals 30 liters divided by 240 kilometers. Because you're using liters per gas, right? Per kilometer. So we have 1/8 liter per kilometer. So I'm using 1/8 of my liter of gas every kilometer I go. Does that make sense? All right. So units play a role here, right? Your units is your key to know what your independent and dependent variables are. All right. Okay. So is what we just did going to change just because it's a table? No, you still have to be able to identify your beginning and your ending of what you're finding. Okay. So here you go. You have these 2 questions. I would like for you to do them 2 quietly by yourself and then peer check with a group member. Go. All right. So the first part, it asks you to find from 0 to 2. So if I'm finding from 0 to 2, it's letting me know my beginning. My beginning's at 0, 1, and my ending's at 2, 4. Because if it's set up as a table, I know that this is my X and this is my Y. So my A rock equals, what is the change in my Y? So from 4 to 1, that is 3, right? 2 to 0 is 2. So I end up with 1.5, and it's going to be height per meters per seconds. Yes? All right, next is now set from 2 to 4. So from 2 to 4, my beginning is now 2 and my ending is 4. What does it appear that this ball is doing? It's coming back down, right? So if I know it's coming back down, logically I know it's going to be what? Negative. So I'm going down this time. So 1 minus 4 is -3. I am now still over an interval of 2, but now it's a -1.5 meters per second because it's coming back down. Okay. That is average rate of change, guys. All right. You have a performance task. So my challenge for you is that you're going to start on the performance task. I would like for you to spend about 25 minutes of working on it as your homework. And then you're going to have time in class to finish it on Thursday. Okay. Do as much as you can. Set a timer. Give yourself 25 minutes. And then you will resume on Thursday. Okay.